Hey everyone, ready to have your minds blown? Today, we're diving into the world of superconducting computers.
Superconducting computers?
Yeah, we're talking speeds that'll make your head spin and energy efficiency. That sounds like something out of Star Trek, but...
Hold on. Sounds pretty futuristic to me. Is this really happening?
It is. There's this project, Discover Expedition, and they're working to make it a reality.
Discover Expedition. Okay, so what are we talking about here? Building a supercomputer out of ice or something?
Haha, not quite ice, but you're on the right track with the super part. We're talking about superconductors.
Okay, I know superconductors, they're like materials that conduct electricity with zero resistance, right?
Yeah.
But I always thought that was more of a physics lab thing.
You're exactly right. But the Discover Expedition project is taking it out of the lab and aiming to build an actual working superconductive computer.
Whoa, seriously, that's a pretty big leap. What's so special about a computer being superconductive anyway?
Well, for starters, imagine a computer that's not only crazy fast, but also sips energy instead of guzzling it down.
Okay, that'd be pretty sweet. Less guilt about my computer being on all the time.
Exactly. And that's just the tip of the iceberg. We're talking about solving problems that seem impossible today. Things like advanced simulations for climate change or cracking complex codes in a flash.
Okay, now you've got my attention. So what's the catch?
Well, it's not exactly a walk in the park. Building a superconducting computer comes with a unique set of challenges. That's why Discover Expedition has broken down their research into 5 key areas, or what they call thrusts.
5 thrusts. Okay, I'm intrigued. Lay it on me.
So thrust number 1, they call it Super Saucy C design.
Super saucy C. That's a mouthful. What is that?
It stands for Superconductive System of Cryogenic Computing Cores. Basically, it's their blueprint for creating a large-scale superconductive supercomputer.
Ah, so Super Saucy C is like the foundation of the whole project.
Exactly. And they're not rushing into it. They're taking a 2-phased approach to designing the Super Saucy C.
2 phases. Smart. Start slow. Figure things out.
Precisely. First, they're focusing on building on existing technology. You know, got to crawl before you can walk. And then, once they've got a good handle on that, they'll start incorporating all the cool innovations from their other research areas into the mix.
Okay, so starting with a solid base and then going all out with the fancy stuff.
You got it. And that brings us to thrust number 2, circuits and architecture.
So, like the nuts and bolts of how it all works together.
You could say that. This thrust is all about developing the blueprints for these super-efficient systems. They're even working on a way to tackle the memory bottleneck that slows down even the most powerful computers today.
The memory bottleneck, huh? I've heard about that. Always causing trouble.
Right. It's like having a Ferrari with a bicycle tire. No matter how powerful the engine, you're limited by the weakest link.
So they're trying to build a super fast memory to keep up with these super fast processors. Ambitious.
And that's not all. They're actually researching superconductor memory itself, something that's been a major hurdle in the past.
Now that would be a game changer. Imagine a computer that boots up instantly and can access information just as fast.
Exactly. And it highlights how they're not just focused on raw speed, but on optimizing every aspect of the system. But hold on tight, because this is where it gets really cool, literally. Thrust 3 is all about devices and materials, and let me tell you, they're diving deep into some cutting-edge stuff.
Deeper than superconducting memory? What could be cooler than that?
Think new materials and designs for the superconducting devices themselves. We're talking about materials with names like, get this, 2Fuck is JJs.
Okay, you lost me. 2Phi and Phi JJ sounds like something out of a physics textbook.
I know, right? Basically, these are types of Josephson junctions, which are these tiny components that are crucial for superconducting circuits. Think of them like the transistors of the superconducting world.
Okay, so by experimenting with these different materials, they're aiming to make these Josephson junctions even better.
Exactly. They're trying to find the perfect combination of materials and configurations to squeeze out every ounce of speed and energy efficiency from these devices.
So it's like fine-tuning the recipe for the perfect superconducting stew. They're even working on a new type of memory cell.
Oh, yeah. And it's not just any memory cell. This one's small, energy efficient, and can retain data even without power, and it's fully addressable.
Wow, that's a mouthful. But hey, if they can pull it off, who knows what kind of impact that could have. But with all these incredible components, they've got to find a way to make them all work together, right?
You're preaching to the choir. And that, my friend, is where things get even more mind-boggling. It's thrust number 4. Integration and interfacing.
Integration and interfacing, huh? Sounds complicated.
You have no idea. Imagine having to connect all these super cooled components without losing any efficiency along the way. It's like trying to build a house of cards in a hurricane.
Yeah, one wrong move and the whole thing could fall apart. So how are they even approaching that?
They're exploring all sorts of new technologies, like passive integration technology, which basically minimizes the need for bulky and inefficient components.
Ah, so it's about streamlining the whole system.
Yeah.
What about the data itself? How do they get it to flow smoothly between these super cooled components?
They're looking at high throughput active interfaces for that. Think of it like building super fast data highways between all the different parts of the computer.
Data highways? I like it. But this all sounds incredibly challenging.
Oh, it definitely is.
Yeah.
But that's what makes the Discover Expedition project so exciting. They're tackling these challenges head on, and they're thinking about the bigger picture too. It's like they're trying to reinvent the wheel, but make it go 1,000 times faster and on an ice rink.
Pretty much. And they're not just stopping at the hardware, are they? They're thinking about the whole ecosystem.
Exactly. They know that a super fast computer is useless if you can't actually, use it.
Right, like having a sports car but no roads to drive it on.
Perfect analogy.
Yeah.
And that leads us perfectly to Thrust 5, business and socioeconomic impacts. This is where they step back and look at the bigger picture, like how this technology could change the world.
Okay, so less about the nuts and bolts and more about the art of the possible.
You got it. So imagine this. Data centers that use a fraction of the energy they do now. We're talking about the potential to be like over 100 times more energy efficient.
Over 100 times. Now that's what I call going green. Think of all the energy we could save.
Right. It'd be huge for businesses, the environment, pretty much everyone. But energy efficiency is just the beginning.
Oh, there's more. I'm all ears.
This tech could revolutionize fields that need massive computing power. I'm talking climate modeling, drug discovery, even things like advanced AI. Imagine the problems we could solve.
Okay, now I'm really starting to see the potential here. But come on, let's be real. What are the chances they can actually pull this off? There's got to be some serious roadblocks, right?
Oh, absolutely. I mean, one of the biggest challenges is just the sheer complexity of this tech. Superconductivity, keeping things super cold, integrating all these delicate components, it's no easy feat.
Yeah, it's like trying to build a computer out of snowflakes. Sounds beautiful, but good luck keeping it from melting.
Right. And then there's the issue of scalability. What works in a lab setting might not translate to building these systems on a larger scale.
So it's not just about proving it can be done, but figuring out how to make it practical and cost-effective in the real world.
Exactly. And all of that before we even get to the software side of things.
Software. Right, because we can't just load up Windows on a superconducting computer, can we?
Not a chance.
Right.
We're talking about developing entirely new programming models and algorithms to really take advantage of this whole new way of computing.
So not only do they have to build the car and the roads, but they also have to write the driving manual from scratch. That's a tall order.
It definitely is. But that's what makes this whole thing so fascinating. It's like we're on the cusp of something truly revolutionary, but, with a lot of hurdles still to overcome.
Yeah, exactly. It's not like we're going to be trading in our laptops for superconducting ones next year.
So, not exactly a plug-and-play situation, huh?
Yeah.
When can we realistically expect to see this technology in action, even if it's just in those big research labs?
Well, the Discover Expedition folks, they're aiming to have a working Super Saucy's prototype, but even that's a big if and a long way off.
Okay, so maybe hold off on buying that superconducting gaming rig for now. But seriously, even if it's decades away, what you're describing, it's like a whole new era of computing.
It is. It is. Think about it. Faster computers, that's one thing. But the things we could do at that speed, the problems we could solve, that's what's really mind-blowing.
It's like we're peeking through a keyhole at a future we can barely imagine. Climate change solutions, new medicines, AI that's smarter than we can even comprehend right now.
And who knows what else? Things we haven't even dreamed of yet. That's the beauty of these big, ambitious research projects. They push the boundaries of what's possible.
And remind us that there's still so much out there to discover. It's inspiring, really.
It is.
Well, I think that about wraps up our deep dive into the world of superconducting computers. It's been quite a journey.
It has.
For anyone listening who's as fascinated by this as we are, we'll be sure to link to the Discover Expedition project in the show notes so you can keep up with their progress.
Definitely worth checking out. Lots of cool stuff there.
And who knows? Maybe one of you listening will be inspired to pick up the torch and lead the way to this superconducting future. Thanks for joining us, and until next time, keep those minds curious.